You will get a question on your screen. Please press OK. Okay, hello and welcome. Welcome to the fourth webinar, the last one of the series, Crime and Place in the Making. I'm Vania Secato from KTH, the Royal Institute of Technology here in Stockholm, Sweden. This series is a collaboration between the KTH Network Safe Places and the American Society of Criminology Division of Communities in Place, the DCP. Today's topic is artificial intelligence, AI, machine learning, and related technologies in criminology. And with us, we have four speakers. Dr. Yuhao Kang, the University of Texas at Austin, Dr. Riley Tucker, the University of Chicago, and also a student panel, Cheyenne Hodgen, the University of California, Irvine, and Maya Moritz, the University of Pennsylvania. The webinar session examined AI and machine learning applications for understanding safety perception, urban design, crime, and environments. So you will see a little bit how these things goes together. We are going to have a presentations combining Google Street View with AI to capture subjective perception. In other cases, is to demonstrate machine learning potential for tracking long-term property development. In other cases, looking at the techniques of optimizing annotation of images. So it will be, as we say in Swedish, is smorgasbord of the use of this new technology in criminology. So I'm really looking forward to listen to our to the speakers. The webinar has three parts: the introduction, the topic presentation, and of the four speakers, and the discussion. So if you want to make a question, please put your question in the Q&A function at the bottom of the screen. And the webinar normally is about 1 hour long, and we hope to make the recording available for you later on. And so that's all, I guess, from me. I just would like, with further ado, I would like to pass the word to my co-chair, Corina Graf, who will introduce herself, and also the today's speakers. Welcome, everybody. Welcome, Corina.
Hey, everyone. Thanks so much for joining us. Thank you, Vanya, and everybody in Vanya's team for your help in organizing this. And I'm so grateful to the speakers who volunteered your time to share from your knowledge with our large audience. I'm Karina Greif. I'm Associate Professor at the Penn State University in the Sociology Criminology Department, and chair of the DCP, the Division of Communities in Place at ASC. And in my function as chair, I want to bring to your attention to, several pieces of information. I want to say congratulations to our new board members. We have a new chair-elect in Lindsay Borges, a secretary-treasurer, Alyssa Chamberlain, a new student member, Casey Kendall, who will join the team. Congratulations, everyone, those who were elected, and also thank you to all of you who have voted. Such an important part of the process in our division, creating community. And I want to draw your attention to several meetings and panels. We sent out a newsletter, but if anybody's missed that, please reach out to me and I'll forward it to you. Two important events. We have a reception on Thursday, November 14th, between 6 and 8 offsite at the Fang restaurant. Please be there in San Francisco. And then on Friday, November 15th, early in the morning, 9:30 to 11, an awards ceremony. So we would love to acknowledge all the awardees and to see everyone at either or both of these events. Then, of course, we have a long list of session-sponsored panels, so I won't go through all of them, but I'm really hoping that you will be excited as I am to attend some, if not all of those. All right, our speakers today. Thank you so much, Dr. Yuhong Kang. He directs the GIS Sense Lab at the Department of Geography and Environment the University of Texas at Austin. He has a postdoctoral research at the MIT Sensible City Lab, received his PhD from the University of Wisconsin-Madison, and earned his bachelor's at Wuhan University. He previously worked at Google X and Mobike. His research mainly focuses on human-centered geospatial data science to develop cutting-edge geospatial artificial intelligence approaches and GIS and address real-world problems. His work has broad applications across public health, urban planning, criminology, and real estate sectors. So thank you so much for joining us. Our next speaker is Riley Tucker, Dr. Riley Tucker. He's a postdoctoral scholar at the University of Chicago with Environmental Neuroscience Lab. His research uses computational methods such as machine learning, natural language processing, and web scraping to better understand why some places have more crime than others. Thank you, Riley, for joining us. This is our first time, Vanya, I don't know if you mentioned, this is a wonderful opportunity for us to highlight the work of some of our bright students in the division. Cheyenne Hodgen is a third-year Criminology Law and Society PhD student at the University of California, Irvine. Her primary interests include crime in place, the built environment, crime prevention, and spatial inequality. And last but not least, Maya Morris at the University of Pennsylvania. She's a doctoral student with the Department of Criminology there, where her work explores policing, legal regime change, and place-based changes, including street art and gentrification. She completed her bachelor's in economics at the University of St. Andrews and master's in science and economics at the University of Mannheim. She has also served in research assistant science communications roles at the Heidelberg Institute for Geoinformation Technology and Jesse Leibniz Institute for the Social Sciences and St. Andrews School of Economics and the Rotman School of Management. All right, without further ado, thank you so much again to all of you for all the presenters and all the participants. So I'll give it over to Dr. Yuhan Kang.
Thank you, Karina, and thank you, Vanya, for the kind introduction and invitation. Hi, everyone. I'm Yu Hao Kang. I'm currently an assistant professor at the University of Texas at Austin. So today, my presentation is entitled Assessing Subjective Safety Perceptions in Stockholm with Artificial Intelligence, including both opportunities and challenges. So next page. So at the beginning, I would like to ask a question. So have you ever participated in some safety perception related survey before? So actually in Stockholm, in Sweden, the urban planning, the city planning office will distribute the safety perception survey for every 3 years to collect citizens their sense of safety in their neighborhoods. So as you can imagine, like survey-based methods may always have some need more labors and it's time consuming. So is it possible that we have a more effective way to measure and to quantify human safety perceptions, such kind of subjective feelings towards the environment? So fortunately, recently we have some emerging technologies such as the urban visual AI using artificial intelligence, which can help us to understand and modeling our digital environment. Then in this case, is it possible that we leverage such kind of cutting-edge urban visual AI methods to understand human safety perceptions in response to different environmental settings? Next page. So traditionally, to collect human safety perceptions, we often use methods such as self-reports, surveys, and mental maps. but they have some limitations, such as they are restricted to small scales, they are labor intensive, and they are time consuming. So then the question is, next. Then the question is are there better ways to measure human perception of place to reduce labor, such kind of like limitations, like to reduce the labor and time cost? So here we propose to leverage spatial data science methods by combining street view images and deep learnings to do so. Next page. The hypothesis of this workflow is that the participants' perceptions of street view images are treated as a proxy of their perceptions of the built environment. So as you can see here, I just want to show two sample street view images at UT Austin. These street view images showcase the detailed landscapes and the streetscapes alongside the road. And we can treat them as a proxy of the built environment, and people's interactions with these street view images may be treated as their perceptions of the built environment. So following this principle, we further design an online survey. Next slide, please. So as you can see, we created an online survey in Stockholm in Sweden to collect human subjective safety perceptions based on street view images. We ask our participants to compare two street view images, which place looks safer or which place looks less safe, and they need to pick up the image that looks safer or looks less safe. It should be noted that all participants live in Stockholm, and we further recorded participants' age and gender. Next slide, please. So after we collect such kind of survey to collect human ratings on different street view images, then we can leverage some cutting-edge AI methods, such as this one, a deep learning model, DenseNet, which can be used to measure human perceptual scores of a given street view image. After we train such a model, such an AI model, for any given street view image, the output of this model would be the human perception scores, such as the safety perception scores. And the higher the score, the higher safety perceptions that people perceive of the built environment. Next slide. Here, I would like to showcase some images, some sample images. As you can see, there are two groups of images predicted based on the AI method. Those images that with high safety scores are on the top, and those images with low safety scores are on the bottom. So we believe that these two groups of images also fit and align with our common sense, right? So they may also make you feel safe or not safe. And based on such measurements, we further create a map on the right to show the distributions of such AI-based safety perceptions. Next slide. So because of this, we can further understand what variables that contribute to safety perceptions. We identify some key factors such as high quality of the neighborhood of visual appearance, inner city views, and prosperous economy are positively associated with safety perceptions, while certain types of urban facilities are negatively associated with safety perceptions. Next slide, please. As you can see, although we leverage AI methods to quantify the safety perceptions, but they indeed brought some opportunities to help us understand the subjective safety perceptions. But we are also notice that some potential bias. So we ask, is a place that appears safe really felt safe by its residents? So based on this, because of this question, so as I mentioned at the beginning, the City Planning Office in City of Stockholm distribute a survey for every 3 years to collect human subjective safety perceptions. So are there any bias between these two methods, considering the nature of these two methods, like the traditional approaches may more rely on personal experiences, while AI-based approaches may more rely on human visual perceptions of the built environment. So are there any difference between these two methods of safety perceptions? Next slide. So here with an overview of the safety perceptions using survey. we pick up 3 important questions and construct another index to showcase the safety perceptions from survey. And on the right, we show another map to showcase the survey-based safety perceptions. Now we have 2 measures, AI-based safety perceptions and also survey-based safety perceptions. Then we calculate their difference, which we so-called the perceptual bias and perception difference. Yeah, next slide, please. So as you can see, there are, generally speaking, these 2 measures have similar patterns, but they also have some differences. For instance, we find that vibrant places may look safe, but felt unsafe by its residents, while neighborhoods with more elder people may underestimate the safety of their living places, and which may enlarge such kind of perception bias. So to conclude, next. To conclude, we believe that AI-based safety perceptions and survey-based safety perceptions have their unique characteristics. For AI-based perceptions, it's more related to visual appearance of the built environment and reflect the instant impressions of the built environment. While for survey-based safety perceptions, it may more encode the daily experience of neighborhoods and with local knowledge of its residents. Next slide. So to summarize, we believe that when we implementing such emerging technologies to support different policy to measure safety perceptions, it indeed brought a lot of opportunities, but we should also consider its nature to understand its characteristics before implementing them into the real world applications. Yeah, that's all. Thanks for listening. Yeah.
Hi, everyone. Thanks for having me. So today I'm going to be presenting some work inspired by the crime prevention through environmental design framework. If you're not familiar with it, I've got the little concept map on the screen here showing you the main concepts. But essentially, it's this idea that urban design shapes how territorial people are, how willing people are to take action against incivilities that they face in their area. And Newman points to a couple of main aspects of urban design that shape territoriality. The first being aesthetics. When people find that the place they live is visually pleasant, they're expected to be more motivated to take action to preserve that, visually pleasant place. But then there's also this aspect of natural surveillance, right? Even if I'm motivated to step in when a problem's occurring, I need to be able to visually see that something's happening to respond to it. So there's going to be these kind of 2 features of urban design, of aesthetics and natural surveillance, which I'm going to be emphasizing in this talk here. Next slide. So certainly criminologists have been testing subTED through different means over time. And I would say the main approach to testing this question has been through an object counting approach. Essentially, we take data from different locations and we try to count the presence of objects that either improve aesthetic value of the space or impede the surveillance. And so there's many different types of objects people have looked at, but a couple of the key ones that you might be familiar with are like the presence of trash, or the presence of vegetation, or kind of presence of fences and walls. And so there's like really good research that suggests that when you count these things, you can explain variation in crime counts, but it's a little ambiguous theoretically because some of these objects kind of have different relationships to these mechanisms. So for example, if you think about vegetation, you can have a really big bushy tree that is like super nice to look at, but you can't actually see through it, right? So you have this object that improves aesthetic value while denigrating surveillance. There's also this bigger kind of theoretical problem that I've come across from hanging out with psychologists, which is that there's this idea in cognitive psychology of top-down processing. And essentially what it means is that our brains are working really fast in the background anytime we're doing something. So when I enter a new space, it's not so much, according to psychologists, that I'm looking around at different objects, but instead I rapidly come to an assessment of what's called the gist of the location I'm in. And so what I was really interested in is if we could measure the gist of images that relate to subTED, that would mean taking an image and putting a score on it for, aesthetic value or a score for natural surveillance. And theoretically, it seems like if we could do that, we should be able to use these numbers to explain variation in crime. So today I'm going to show you a little bit of a machine learning approach that I've used to get these scores on images. Next slide, please. So first I'm going to go over a training data set that I designed for this kind of project here. And so the starting point is about 8,300 Google Street View images that were collected all across Chicago. And so stratified sample with 4 images per block group just to make sure that we have full coverage of the city. And so then I picked 5 different GIST measures that could be used to kind of speak to the septhead metrics. So these first 3 here are GIST measures derived from the psychology literature that relate to aesthetic value. So how much do you like this image? How complex is this image? And how memorable is this image? And then the second 2, and I can see I have a typo there, these measures of transparency and enclosure are expected to relate to natural surveillance. And just to get a sense of what it means to get a rating of these images, you can see this plot in the lower left corner there is what's called the fast rating image task. And you can imagine a participant is shown 12 images in the grid like this, and then they're given a prompt. So in this example here, we have the prompt for what's going on inside of the buildings. A user picks 4 out of 12. Then they're shown another grid of 12. They do this many times, and then many people do that, and we can calculate the probability of an image being chosen. So we get these ratings through an online platform called Prolific. Across all 5 measures, we get 60 raters per image, which ends up being about 2.5 million ratings from 5,000 people online. Next slide, please. So for each of these, we have 60 ratings per image, and so then I use this as a training data set for a machine learning model. And so you can think of we have 5 separate machine learning models for each GIST. And so I train them using a ResNet transfer learning framework. And so to think about whether this machine learning approach is actually working or not, I use a pretty standard train test split strategy. And so what that means is that if you look at this map on the right, so we have human ratings for images in all of these places. The gray polygons were shown to the AI, and the red polygons were held out at the AI. And so what that means is that if we show the images from the red polygon to the AI, we can actually see how close the AI is doing to the human ratings. And so the result of that is then in this plot in the middle here. And so the x-axis is the AI predicted scores, the y-axis is the human rated scores, and each dot is an image. And so here we see that the AI predicted scores correlate to human ratings at 0.89. Really strong correlation, essentially suggesting that if we show these images to the AI, it does just as well as a human would do in rating them. And so we can use this to then measure ecometrics at a much larger scale. And so what I did is I collected about 200,000 images from Chicago, just like sampling off the street network. We feed all of the metrics into the AI to get their GIST scores, and then we average all GIST scores from images in the same neighborhood to create some neighborhood ecometrics that represent these septet variables. And so then if we look at the next slide, we get these really pretty maps. And so on the right here is one of the GIST that relates to natural surveillance. The areas that are like the deeper blue polygons are where it's harder to see through the environment. So if you're familiar with Chicago, this area in the Northeast where it's really hard to see through is like where all the buildings are. It's where you've probably been if you've been a tourist in Chicago. And then as you go out to the periphery of the city, it's kind of easier to see through things. And then, on the left is one of our maps that relates to aesthetic value. And you kind of see an opposite pattern, right? In like the touristy downtown area of Chicago, where all the fancy buildings are, you can see it's really complex. And then actually you can like see that East Chicago in kind of like I guess it would be like the eastern side of the state or the city pops out, which is kind of interesting. But in any case, we get these like really strong ecometrics here. And when you calculate the ICCs, we find that there's like a ton of variation in these image scores across neighborhoods, right? So we have evidence that there's a real neighborhood phenomenon going on here. And certainly in a 7-minute presentation, I didn't have time to put in a bunch of tables and numbers. But what I can tell you is that when we put these measures into some lasso regression with a bunch of other things that criminologists care about and also object counts, we find that these GIST measures are associated with both territorial behavior in neighborhoods and also several kinds of crimes. And so if you want to see those numbers yourself, you can come see my ASC presentation next Friday and you'll see all the numbers there. Thanks again for having me. Looking forward to Q&A.
Hi everyone. Today I'm going to be sharing some of my work which is focused on the use of historical Google Street View and specifically evaluating this as a measure and a method of measuring change in the built environment using machine learning. Next slide, please. So as the other presenters have demonstrated today, Google Street View and machine learning are great tools for measuring the built environment, and they make it really easy for us to do so on a large scale. Historical Google Street View actually offers us images dating back to 2007, and so it provides us a potential way to measure change over time. And so the goal of this work is really to assess it as a method, seeing how well it can measure change as well as what the limitations are. To do so, we're focusing on the city of San Diego, California. For the purpose of this presentation, I'm just focusing on the small area just for ease. And we have images from 2009 to 2022. So there are two key machine learning models that we're interested in. The first is semantic segmentation, and the second is the YOLO object detection model. Which differ in slight ways, but ultimately they're both used to objectively measure elements of the built environment, such as buildings or cars or CCTV cameras. For the purpose of this presentation, I'm focusing on semantic segmentation, but I'm happy to talk about either of these in Q&A. Next slide, please. So the first step in this work, of course, is downloading images. We did so in 20-meter intervals along the street network to ensure that we were capturing the majority of the environment. Overall, for this study area, we had about 17,000 unique points, and for these, we had 113,000 images, which means we have an average of 6.6 years per point. The table and the map here on the right show the variation in the availability of images. So as you can see, there's like a temporal variation where some years have relatively few or no images. And there's also a spatial variation where some areas are missing images from different years. Next slide, please. So once the images are downloaded, we run them through the semantic segmentation model. This is trained on streetscape data, so it's very useful for Google Street View images. And what it does is it predicts the value of each pixel and places it into one of 19 categories. So this image at the bottom is an example of what this looks like. You send in the original image and it will predict each pixel based on these categories. So roads, buildings, sidewalks, etc. Ultimately, we can then use these numbers to calculate the percent of each image or that is made up of each category. So the percent of building in a specific image. Next slide, please. So we then do this for each year, and because which image is the left or the right side of the street varies just based on the direction that the Google Street View car is driving that year, we average the values for each year. So in this example, the top and the bottom image represent the left and the right, and so we're taking the percents for both of these and averaging them out. So in 2009, the two images, top and bottom, have an average of 16% buildings and 11% vegetation, just as an example here. And as you can see, there's some variation in these percentages, and this doesn't seem to be related to any substantial changes in the environment. And so I'll come back to this when I talk about some of the limitations. Next slide, please. So based on the percents that we have calculated for each year, we're then able to look at how consistent the numbers are for each point, or basically how much change there is. So these two maps I just plotted to show the standard deviation for both the percent of vegetation on the left and the percent of buildings on the right. So the larger and darker spots are those that seem to have more change in the numbers for each year. So a higher variation in the percent of vegetation or the percent buildings for that given spot over this time period. As you can see, it's kind of hard to see, I'm sorry about that, but there's mostly consistency with points that are closer to each other, which is a good thing. However, I'm going to talk about some of the problems we're seeing with this approach too. Next slide, please. Yeah, so we're obviously very early into this project. It takes a long time to download and run millions of images through models. And of course, while it's a promising method for measuring change, it still has a lot of limitations. So I'm going to talk about these briefly now. First, we're seeing the uneven availability of images. Ultimately, you're relying on when the Google Street View car passes through a specific location. So some areas you're just not going to have images for specific years. You might not have at all, depending on whether that place is publicly accessible to Google or not. We're also seeing a lot of seasonal effects. So this is specifically related to vegetation, which loses, trees lose their leaves in the colder months. And when this happens, the model is not detecting them as vegetation, but rather picking up what is behind the tree, which leads to these weird spikes in both the percent of vegetation as well as the percent of whatever is behind it. Related to this, we see some false changes that are being detected. So where the percent is changing, but it doesn't seem to be related to any actual change in the environment. So this example here shows one of this where the angle of the image shifts dramatically, changing the percent of the sky, the building, and the sidewalk. Another thing that we've noticed is that there's changes based on the lane that the car is driving. So if it's more central or it's in the side, like closer to the sidewalk, it's capturing things from a closer angle. So they're looking larger, and this is impacting the percentages. And so all of these are things we're working to address right now and see, how well we can account for these sort of limitations and measure actual change. And so for some next steps, we want to compare to other measures of change. So looking at permit or building construction data. We also want to account for seasonality. So, right now we're at the annual level, but going down to monthly images and seeing how that looks. And then also testing the other models. So object detection models may avoid some of these limitations, but they also may come with their own challenges. Next slide. Thank you. And if you want to know more, I'll also be at ASC and I'm happy to answer questions.
Hello, my name is Maya Moritz. First of all, thank you so much. These were all wonderful presentations so far, really amazing. I'm here to talk about my project, Don't Fire Your RA, using ChatGPT to annotate place-based changes, which I'm working on with my co-author, Dennis Aumiller. So next slide, please. So this arose out of the other project I'm presenting at ASC, which is the effect of murals on crime. And I didn't want to just stop at crime. I wanted to look at which mural attributes matter and the disorder around a mural. But that data is not available, so I need to make it myself. I have 600 murals. I have many time periods. So the question was, can ChatGPT just do it for me? So the way I experimented with this is I gave ChatGPT 1 or 2 input images like those shown on the left of this slide. And I prompted it with several types of prompts. One example is at the bottom. So you're a highly sophisticated annotator. Here's a number of different categories to annotate, and here's what to give me. And it resulted in this desired output on the right, which talks about whether there's males in the mural, how much graffiti there is on it, how green the street is, things like that, the kind you might get from a human. And then I compared that to actual humans doing this task. And that yielded, next slide, please, this table. So this just sums up the results. I'm comparing 4 strategies for annotation: an expert annotator, and that's me; a student annotator, that's my research assistant; an untrained, like Mechanical Turk style annotator, these are preliminary results; and ChatGPT with the best prompting strategy we were able to come up with. And I've bolded the winner in each category. So ChatGPT by far wins for cost and time, just unbeatable. 1 cent or less per mural, 10 seconds plus time extracting images. However, the really important part of this table is accuracy, because if we have a fast and cheap system, does that really matter if we're not getting something useful? And using myself as 100% accuracy, I found that my student RA, the research assistant, agrees with me about 72% of the time, but ChatGPT agrees with me about 68% of the time with the best optimized model. So that's pretty amazing. To me, this says that, yeah, I can use ChatGPT for this. So that's the ultimate finding. But let's dig a little bit into that 68% number. So next slide, please. So one thing we did many things, but one thing we did is we looked at how to set up the model. That's what the hyperparameters are, like the settings on the model. So these are going to be on the x-axis here. Ultimately, we'll find photos and resolution matter, but let's dig into how. So the way to read this graph is that the tan bars are the percent accuracy, how much ChatGPT agrees with me. And the white bars are the variance. And the scale is on the right. So it's not that variance is half to more than half the size of my mean. I've included two more lines, a red line, which is just the strategy of random guessing. That gets you about 30% accuracy, as well as a strategy of always guessing the most frequent value. So if litter has the most frequent value of 2, I always say 2, regardless of how much litter is in the photo. That gets me to 65% accurate. That's pretty amazing. But so that's what we want to beat, really, with ChatGPT. So we start on the left with our hyperparameter or setting of mini, the smallest model, cheapest model, compared to the next to it, 4.0, which is 10 times the cost. And we do see this improvement in performance and a fall in the variance, which is exactly what we want to see, but it comes at 10 times the cost. So that's considerable. In the middle grouping, we're playing with something called temperature. That's a randomness of the generation. So how random do I allow this to be? And as we raise it, actually no increase in performance, but a lot of increase in variance. So that's not something we want to do. Keep that at 0 in the setting at least. And when we move to the right side of this figure, I'm bringing in 2 photos instead of 1, already a nice improvement. I'm bringing in high resolution instead of automatically calculated resolution. Now we're beating almost most frequently purple line strategy. And when I combine those two, we're well beating the strategy. So that's what we found is the optimal setup for this sort of task. And I should note that this last configuration is a fraction of a cent more per mural. It's not 10 times more per mural. So this is the cheapest, best way to make ChatGPT work for you. Next slide, please. So I'm going to skip to the results because we're time limited. So what's happening here is I'm comparing 3 setups. The tan bars are baseline ChatGPT. That's this naive prompt, the kind of thing I wrote before starting this project, not optimized settings, and just run very simply. The green are going to be the best setting, so best prompt that we tested, best optimized settings, and the blue is going to be my research assistant, so a human comparison. And I've grouped this, and each height is percent accuracy, how much they agree with me. I've grouped this into tasks, the 14 tasks I gave ChatGPT, which are everything from, are there women in the mural? How green is the area? Are there abandoned buildings? Things like that. There's a traffic light system at the bottom, and that tells you in red when ChatGPT performs worse than my research assistant. In green, when ChatGPT performs measurably better than my research assistant. And in yellow, when ChatGPT performed better, but it's not like super measurable. So ultimately, there's a bit of a pattern here. And that pattern is on the left of this table, of this graph. My RA is winning. And that's because it's to do with the mural itself, with the people in it. So when you have people tasks, you might prefer a human. They're much better at things like race. I think ChatGPT is quite conservative there. And on the right, we have things to do with the environment around the mural. And ChatGPT can outperform a human there, at least in terms of agreeing with me. So if you have a project that's not about people, it's not about art, ChatGPT is a really wonderful way to go about it. So next slide, please. So ultimately, the goals of this project are create a guide for the average social scientist who's not a super exciting machine learning researcher or something, to using vision language models or VLMs to annotate visual data. So ChatGPT. So how to do it and when to do it. I want to create this cost-benefit analysis like I did here, but with more detail, as well as a deeper understanding of the possibilities and limitations of things like ChatGPT in this space, so you can use it for your experiments. There's so much more, so please come to our session, details listed there. Thank you so much for having me.
Wonderful. Thank you so much, Maya. I don't know, Vanya, if you want to take it over, but I can start. I see questions in the Q&A. If you guys have any additional questions as we move into answering these, please upload them or write them in the Q&A box. Vanya, I'll give you the floor if you want to mention anything else before we move to the questions. But I do want to say thanks so much for all the panelists. What a wonderful set of projects. I'm really excited to be hearing about the progress on these, and now looking forward to the discussion.
Yes, I just wanted to say the same. I think it's very interesting, the different methodologies and the similarities, the search for, looking for indicators and trying to use, new methodologies instead of, doing the traditional ones, which are quite costly. So I think it's one of the things that we could explore. I have seen also uh, uh, questions here. Do you want to take the first?
I can start, yeah.
Yeah.
Right. The first one asks, how does the AI defensible space approach differ from what that of Oscar Newman's? What about gated communities, neighborhood safety then and now? I think this is probably relevant for all of our speakers, but if anybody wants to start, just chime in. I know, Riley,
Sure.
you've been thinking
Yeah.
about theory quite a bit.
Yeah, happy to jump in. So for me, when I was designing my project, I was kind of trying to design a test of Newman's ideas, right? Like to me, I like literally like I was like cool, people doing cool stuff with computer vision. Maybe this speaks to Newman's ideas. I sat down and I read the book. And to me, I kind of came up with these hypotheses about natural surveillance and aesthetic value. And defensible space has kind of an interesting place in the literature because I mentioned people have been counting a lot of objects. And there's certainly been people that are counting gates and fences, as you mentioned, as a measure of territoriality. But it's really interesting because fences also are impacting natural surveillance, right? Like a wooden fence you can't see through, but like a chain link gate you can see through. And like these also have different implications for aesthetic value. And so I'm really interested in kind of moving away from like thinking about like specific objects to think about how do these objects actually relate to like how defensible is a space, or how aesthetically pleasing is a space. And I think like there's a lot to read into on the objects, but we'll probably get to a point where we're thinking about like different kinds of gates. You know what I mean? Like the fact that this place has a chain link fence versus a wooden fence might be really meaningful and informative about like how well that place is insulated from crime, but also like the social character of that place. So I definitely think that there's a lot to think about in terms of gates. I think we just might need a little bit more theory to think about in terms of how.
Great. Thank you, Riley. We have a number of other questions, and one is, for instance, specific to Dr. Kang. Were there any specific features of the build environment that had a strong impact on the safety perceptions based on your findings?
Yeah, thanks for your question. So this is a really very good question. So for the objects, there are actually two levels. One is at the neighborhood level, and one is the element level in different 3D images. So in the presentation, what I mentioned was at the neighborhood level. So we examined the different neighborhood level variables such as land use types and certain social demographic information. We noticed that overall, we think high quality of the neighborhood's visual appearance and inner city views and prosperous economy, those factors, those related factors such as like um, business or business regions, those kind of land use are positively associated with safety perceptions. And also we noticed that it might be different from Sweden and in US because in US most of the downtown areas might be dangerous than suburban areas. But it seems that in Sweden, inner city or core city regions might be safer. Yeah, so this is very interesting, like regarding the cultural differences and continental differences. So that's at the neighborhood level. And we also have another ongoing work to examine the features from street view images. We noticed that several street features such as trees, the greenery, and pedestrians, and road networks, like the proportions of road networks, they are either positively or negatively associated with safety perceptions. Yeah. So the two levels, one is at the neighborhood level. This is what we did in our paper that I presented. Another one is at the urban feature level, based on street view images to identify different features to understand what features are associated. Yeah.
Thank you, Yohao. I have a very basic question before we move on to other. Are there, and this can be to anybody, is it, what are the other kinds of sources that we would use we talked a lot about Google Street View, right? And I have been observing my students here from computer science trying out other kinds of sources. Is there anybody that has already tried the other kinds of sources more than Google Street View?
So I know Marco Helbig in the Netherlands have been doing some pretty interesting stuff with thinking about like crowdsourcing these images. You know, just like having people upload their images, and they have like a platform, where you can look at all of them. And it's like really cool. You get out of like the scope of Google, but it's like kind of hard because you're relying on the people to fill out the images. And then you have all these things with like different angles and stuff, so it's not as systematized. I think that's like a big picture issue for us to think about. But yeah, that kind of like crowdsource thing is super cool.
That's right, yes. Does anyone want to comment on that also?
Yeah, there is an open source platform called Mapillary, which
That's right.
provides open source street view images. Yeah.
Mm.
And also in different countries, the street view image platforms are also different. Like in Russia, in China, they all have their own data formats, data platforms. Yeah. And also like in Africa, perhaps in some countries in Africa, we may need some other data sources.
Mm.
Can you write out the name of that platform? Because we had conversations about that in Philadelphia and had real concerns about people feeling their privacy violated. But so if someone could type the name of that platform, that's super interesting.
Yeah, I can type in Mapillary. Yeah.
Mapillary, yes. You might see, for instance, people, mothers with prams. It's the field of view can be very different from Google Street View, but it depends on what I guess you want to do. It can be interesting in some aspects, but there are holes in many parts of the city here, at least in the sample I have seen here in Stockholm. We have a number of other questions here. For Maya, this is about the conference, right? Will the 15th of November conference be online, recorded as well? I guess it's only going to be face-to-face in San Francisco, unfortunately. Corina, do you want to take one of these
I can take one.
long one here? We can help each other.
I can suggest that perhaps after the last updates to the conference is next week, so perhaps your PowerPoint presentation won't be that different. Maybe we could consider uploading it to where we will upload this webinar along with the slides. Of course, it's up to you, Maya. Okay, so I have a comment from someone saying, interesting conversation. I can see the efficacy in so many other industries, such as military and police. There's no question here, but it does seem very relevant to ask a question abroad. We had a very limited time because we wanted to include everyone in this panel discussion. But if you would like any of you, or maybe even all of you, to elaborate a little bit more on the implications for research, theory building, as well as possibly policy implications of your work and your findings and these methods. Maya, you brought up the issue of privacy. Perhaps we can keep that a little separate. I do want to get to it, but let's talk about implications first, if you would.
Yeah, I mean, to me, it's like a really exciting time for ecological measurement. for kind of like 20 to 30 years now, people have been trying really hard to measure the visuals of places at scale. It's been really hard. Samson and the PHGCN, they had these cars that they were driving around, but they were like sampling blocks from neighborhoods. They were getting like a very small sample of visuals, and they did all these like amazing kind of like broken windows papers. But like today, we don't need these small samples anymore. I think, all of our work are showing that there's different strategies that you can use to like literally just like measure visuals like building by building essentially. And so I think it's really exciting. There's not so much visual theory in criminology, but there's a couple of these visual theories that are super famous. Like broken windows theory is a visual theory of crime. So I think that now that we have tools that we can actually test these visual theories, it's just like a really exciting time to be a criminologist. I think we're really at the beginning here. I think there's going to be a lot of cool theories and stuff that are spinning out of this. So yeah, I think like, I don't know, between this and the large language models, it seems like research methodology has been turned on its head completely in the last like 2 to 3 years. So I think it's a really exciting time for this stuff.
Yeah, I also think that in a more, less necessarily research focused, a more general sense, we could see what happened to policing with hotspot policing happen to professions like city planning and government planning. And you could use this to sort of decide which areas of a city really need help, really need to be fixed up, need attention. And that could expand to really anything. I think military and police are probably far beyond that in terms of how they're using data.
I would also just add that, at least for me, something really interesting is the ability to go back in time and look at this change. It's not possible without sort of these methods, and Google Street View is like the one visual way we can do this. And I find that interesting for theory, but also just in a more general sense of like seeing change in the environment. Because I think that's sort of, there's a little bit of work lacking there where we could sort of expand on it now.
Yeah, thanks for all of these valuable insights. So for me, because my background is more like in GIS, in AI, so I'm kind of the technical guy. So for me, I think the one implication of this is we showcase how AI, how these emerging technologies may benefit different policy sectors. For instance, like previously, we already have such kind of cutting edge methods like using AI to quantify the environment. But what's next? How can this be implemented? How can such kind of technology be implemented to benefit our real society, to solve the real problem? I feel there is a gap, a huge gap between like AI developers and different sectors in society. So I think our studies, all of these studies showcase that on two sides, we should collaborate. We should have more communications to understand how such kind of emerging technologies may benefit the real world practices. Yeah.
Very, very good point, Yohao.
I
The
want
need
to
of
add just a few. So it seems like from the presentations across the board, there's lots of implications for victimologies, feelings of safety, perceptions of safety, perhaps even implications for, like you said, Maya, policing hotspots. Yeah, so there's certainly a technical aspect to it and a theoretical aspect to it, and certainly a policy aspect to it. But it does seem as we are getting more and more excited about the implications for science and urban planners, like you said, Vanya, we're also probably going to need to be very mindful of privacy issues as we start to collect more images. What are the implications? Do you guys want to touch on that? Or Vanya, did you have a related question before we touch on that?
I think that the issue of privacy is to some extent has to go through the ethical approval that we get from our, projects from the beginning. At least here in Europe, the GDPR is something that's enforced in our projects from, day one. So a number of things obviously are limited and read at source. So in terms of ethical issues, of course, I don't know to what extent the image recognition and things like that maybe would be allowed in certain countries. Here in Europe, it's not. So I think I wouldn't be too worried about that because I think we have already institutions in place that will ensure these kinds of the security, privacy, and they are a limiting factor, but they are also there for some reason. And the one you mentioned, for instance, issues of privacy is quite an important one.
But
Yeah.
I wouldn't necessarily dismiss the issue too much because I mean, as much as Europe perhaps maybe ahead of the game here in terms of caring for people on the street, I'm not sure that's. I think the technology is really ahead of what the IRBs, at least in the United States, can even imagine in terms of the potential for benefits to the public as well as potential for harm. This is really an area where we as scientists can contribute because I have no doubt that the business is going to be ahead of the game and may not care so much privacy, but we certainly can speak to the implications for privacy. And I can see your optimistic perspective from the European side. I'm not super sure that on the US we are so as much on top of it yet, but I do think we are in a unique position to speak to the issue of privacy without, limiting the potential for contribution and certainly in a thoughtful, balanced way rather than dismissing things from the beginning, right?
Mm.
And I think
I
there's
just wanted
ways
to
that
bring
we
the US
can,
perspective.
sorry. I was just gonna jump and say, I think there's ways that we can do this research while kind of like minimizing the impacts. So, there's like this research on edge sensing. In Chicago, there's this Array of Things project where they have like 30 cameras all over Chicago. And, it's like constantly monitoring it, but it's not like outputting any video. Instead, you can have like an edge sensor where you have a model running on it. So, like, theoretically, I could have my aesthetic value model, on the edge, just like calculating scores every minute or whatever, and we can get that output without actually seeing like this person walk by type of thing. And like there's always kind of like interpretation issues, and like the Array of Things are like kind of funky right now. Like they see a lot of zebra and pizzas if you look at their data output now, which makes no sense. But like in general, I think thinking of ways that we can get the metrics we want and kind of separate that from like the personal information is like something we should all be thinking about how to do.
Yeah, I think there are so many new sensors that would be there capturing, the city life. And this is something really exciting. A little bit what you are also mentioning. The question is how can we associate this to the dynamics of crime? I have a question to Shaheen. I mean, you have shown some areas that have had lots of change. So my question to you is, are you going to associate that to crime, for instance? Or
Yeah, I think ultimately that is the goal of our work. We started focusing on sort of the method and like I think as I probably pointed out there's like a lot of limitations, some small things that make it tough. I think like right now the challenge we're facing is sort of is there a threshold for like what is a real change in the environment versus what is due to these like weird little quirks of the images and how they're collected. But yeah, ultimately looking at change and how it's related to a whole number of neighborhood sort of level things like crime and that is the goal. Yeah.
Mm. Interesting.
There's
Thank
several
you
more
for the.
questions from the audience. There's a long one. Maybe I'll leave that for a little later so I can get to the smaller one. Someone asks, did you all have to learn all these methods from scratch? I guess that you had to train and make a lot of errors in the beginning. Is it quite niche? And I wasn't taught this at the university a few years ago outside of IT tracks. What are you guys thinking about the training program?
Yeah.
How did you end up um, be so knowledgeable about these techniques, or how do you go about training while doing your research? Maybe I'll start with the ones who already have a doctor degree. Yohao, do you want to say something, Riley?
So the question is like these models are all building starting from scratch.
The question is, yeah, how did you learn these methods? Do you come from an IT background, or do
Yeah,
you need a specific training
yeah. I think I think
course?
this is case by case because my past background is already like in GIS in computer science, so I had such kind of technical background. So it seems that it's not that challenging for me to do so. But I really appreciate like my past collaboration with Vania and Jonathan because I learned a lot from them about the criminology theory. As I mentioned, currently there have been a lot of emerging technologies. They can be used to solve a lot of problems. But for me, like based on my personal experience, I don't know what are those problems in other fields. But I have such kind of technology. So for me, I actually built that from scratch, and I believe there are also some new packages which can easily adapt to different problems. And if you want such kind of support, feel free to reach out to me, and we can talk about some potential collaborations. So I'm familiar with those technologies, but I think for me, the key point is what are the problems that you want to solve? And then let's see how the AI could be used to tackle those problems. And I would like to add a little bit more about my comments regarding the privacy. So what you mentioned were all very insightful regarding the concept of the privacy, like regarding from probably from a macro view. But actually from my perspective, I think the AI, these methods there are also some researchers, they can develop some AI methods which can try to preserve the privacy. In other words, like if AI can definitely pose some privacy issues, but AI can also be used to tackle those ethical issues, those privacy issues in AI. For instance, in one of my past work, to protect the human trajectory, like individual trajectory information, AI can generate some fake trajectories, can generate some synthetic trajectory information. So by doing so, this could be used to preserve the privacy. So my comment is this. I think yeah, AI can pose some privacy issues, and it's good that you can summarize such kind of issues. And with the development of AI, it is also possible that we have some more advanced AI methods to address those privacy issues. Yeah, so that's my comment.
Yeah, for sure. No, there's like a interesting project at U Chicago where they're like, it's called like Poison Ivy or something, but it's like a way of like using ChatGPT to like take text and kind of like mask it for ChatGPT in a way that like the human eye can't detect anything. So there's definitely kind of like some fancy AI ways around these issues. As far as the question about kind of like personal training, so I personally did not come from like a computational background. I did like my undergrad in sociology, and I like struggled with SPSS or whatever undergrad. But then like as exactly as Yuha was saying, like sometimes problems require certain solutions. So like when I was in grad school, there's a couple of projects I wanted to do where I realized that I'd really need to use like some online based data. I was really fortunate that Northeastern, where I did my PhD, there was like a single Python class for social scientists. And so, with like one class kind of learning the building blocks of Python, it's been relatively straightforward to kind of gradually learn new skills. But also collaborations are really important, in my current role, I'm with a lot of kind of computer scientists and computational psychologists and stuff who have been able to help me kind of pack these things. I remember like 2021, I read John Hibb's paper about the image segmentation. I was like, man, I want to do that, but I have no idea how. And then all of a sudden, like 3 years later, I'm hanging out with all of these, data scientists and stuff, and I'm able to do my own computer vision models, but it did take like several years of kind of like learning the landscape and stuff. So I think, yeah, like you have nailed it. It's like identify the problem that you want to solve and then kind of go out into like your network and stuff and figure out whether there's an AI solution.
Very good point, I guess. Interdisciplinary work, right? With good research questions. One thing that we didn't talk a lot is the temporal variation. Google Street View is normally during the day, and if you were talking about safety perception, most people would feel unsafe during the night. And our pictures are during the day. So, any ideas or anyone want to talk a little bit about those temporal limitations?
I mean, in theory, if you're counting objects, like the number of bushes during the day should correlate with the number of bushes at night. You know what I mean? So I think there's like some low hanging fruit, and maybe we'll all race to it, of just like taking our daytime measures and seeing like how that differently explains daytime and nighttime crime. But then, sorry, my computer's like freaking out right now, so hopefully you all can still hear and see me.
Yeah, yeah.
Yeah, yeah. But there's like some really interesting things that can change like super rapidly. Like one of like the objects that you count is people, right? And like it might be that if you're like a city block at like 105, there's like 5 people there, but then at like 107, there's no one. And I do think we can kind of get around this issue with like a lot of images. It should be random noise, but it's definitely kind of like one of these things I'm not sure we can get around without building our own image data sets, which is like I've been thinking about this a lot, and it's like a really big endeavor. I don't even know if that's like possible without Google's resources. But yeah, I think like there's definitely some issues that we faced. I'm not sure are completely solvable without developing our own sets of images.
Yeah, and the major thing too that would change at night, probably, the bushes aren't moving away, but street lighting is the major factor that's going to determine how much those objects matter, partially. And data on street lighting is, there's a lot of projects on it, but it's slightly mixed. But it's something that definitely needs to be thought about. Yeah, we don't have the image as well, and also like people patterns will have a lot of noise, but there are places where people congregate specifically at night, sometimes for nefarious activities, sometimes just because the bus stop is there. And then we have things like SafeGraph data, which looks at phone movements. The limitations there, of course, especially financial limitations, but more and more universities are getting these sort of licenses where you will have access to it. I think similarly to some machine learning projects, there is a sort of steep learning curve to it. Is kind of the goal of my project that you can use ChatGPT instead of training your own model. Granted, there are learning curves there. You have to parse objects. You have to figure out how to use the API. That's not something taught in most criminology programs. But I guess similarly, I think Riley mentioned Northeastern having a Python class. At Penn, we have machine learning class. We teach everyone R to a very high degree. I think that's proliferating more, but sometimes you do have to seek it out. But one of the wonders of the internet is that there's so many more resources available to those who aren't in programs right now. And it's a steep learning curve, but it's never too late to embark upon it, probably.
Yeah, I'm so glad you mentioned that, Maya. At Penn State, we have this program, the criminology program is doing a dual degree with the SODA program, which is like a social data analytics, where we're really bringing people together from psychology, IST, computer science, and sort of the students teaching each other and learning which classes to take to solve, to learn about data and methods that could help them solve very specific problems specific to their domain, but certainly collaborating across methodological toolkits, that has been quite successful, and it's a growing training model here. I don't know if that's the case, Irvine, Cheyenne.
No, we don't offer classes. So a lot of my learning has been outside of my program. I am fortunate that John Hip is my advisor, and this is work he does, so I at least have some support, but it's been a little unorthodox, I'd say.
There's a lot of initiative that students have to take. It really helps to have a good advisor like you do it there, and who can connect you with people and classes. But certainly, this is really a growing area, and it's to the extent that the departments can keep up with the demand and the need, and the open resources. I think we're gonna keep up with the science too, right? So.
Mm.
Avanya, what's the status of training in Europe? Like, how do you train your students, or how do you help your students get there?
I'm not in a department of criminology, so it's a department of urban planning, and the institute, the KHH, is a school of engineering. We are the odds out in terms of, criminology. So we are surrounded by, engineers, planners, and things like that. Yet, I would say planners or urban planners, they don't have this training either. So it's not typical only of criminology, but we do have here a PGG course, which basically we organize since 2012, which attracts both people from epidemiology, criminology, demography, geography, and what put us together is the methodology. So, but machine learning is not yet part, but maybe in the future will be. Remote sensing data has been explored by one of my PhD students, it's a part of my background in the past. So I do think that people that have an interest in crime in place, this is opening up new opportunities to test new ways to capture the environment. As Riley mentioned, Maya, for instance, mentioned how the ChatGPT was good to show the landscape, but not to capture features of people, for instance. I found it really interesting. So again, we are really at the beginning of the process, very humbly, I would say, trying to understand a little bit of the data and the methodologies, I guess. And obviously, we needed to couple up with people like, you, how, and that would be more knowledgeable on the methodology to be able to answer those kinds of questions that we find relevant for criminology.
All right, we have some more questions
You
for
are
Maya.
muted.
Can you hear me?
Mm.
Okay. For Maya, question says, have you had the chance to try any open source models? For example, LLA.
We still cannot hear you.
Oh.
No, so I can hear you, Karina.
Okay. Maya, can you hear me? Okay.
Yeah.
So I hope you understand this question because I don't. LLA MA 3.290B visions of Quen to VL. Does that ring a bell?
Yeah, so these are so essentially there's a lot of models, right? There's like Llama, there's Claude, there's Cohere. So my co-author works at Cohere. Yeah, you could use a ton of them, but what's great about ChatGPT is that it's quite easy in comparison to the others. So my co-author's a computer scientist, but I'm an economist, criminologist, to sort of set up and get those results that you like. And with open source, that could be a little more complicated. So we're trying to create this guide so that somebody who's not a machine learning person can do this. I think it's super important to test other models, though. You're completely correct because they're open source, and we should be promoting that. I think the focus of my project is making this accessible, but I think that is the step forward to test multiple models to say like, yes, ChatGPT is the most accessible, but Llama is so much better. So if you find that, then you can start. But if I find Llama's not better, then like why bother investing all that time and energy? So that is a really important result that we're going to start looking at. Once we finish with ChatGPT, we have so many more questions. For example, one big thing I have is whether ChatGPT can do more open-ended questions. That's something we're working on now. Things like what's the theme of this mural, which already between the human annotators has so much disagreement. So that's something kind of interesting. And definitely, you're right, Eunice, that is a wonderful and important way forward for this project.
I just want to jump in and say I have the exact same problem with Llama, where like it actually can like get the right answer that you want, but getting it formatted is just like a nightmare and it doesn't really behave. So yeah, there's like value in having a commercial product where people are investing a lot of money in just like something user friendly.
And the same person who asked this question, actually, he has a question for everyone. So I want to acknowledge Yunus Serhat Bikaki. So I apologize if I'm mispronouncing this, but I want to say thank you for taking the time to write all these questions. So for Cheyenne, they're asking, have you considered using Google Street View along with cross-view approaches, such as integrating satellite images for segmentation scanning and then combining them? Also, which segmentation model did you use? Was it meta segment anything model?
Yeah, so no, it's Deep Lab's semantic segmentation model. And on the other question, yes, we have considered and are considering, bringing in different data and comparing it. We're just very early into this project. We're downloading images for about 15 years for the entire city of San Diego, which has taken some time. So we are excited to sort of move forward, and that's something we are considering.
Do you guys use like a cluster, a server, or where do you store all this data? I guess this is relevant for everyone here. It's not just a matter of processing the data, but also a storage, right?
Yeah, so right now it's on 2 of my hard drives. I have pretty big hard drives and then a pretty big computer because we don't have like any resources provided to us. So I've just been sort of doing this. Yeah.
Startup spirit. I like that. That's awesome. Yuho, Riley, Maya?
Yeah, so we have a cluster here at U Chicago. There's actually like way too many clusters that all have their own problems and strengths. But yeah, so we have a cluster that I think I might have like downloaded. My images is not so much, it's like 200,000 images is like 40 gigs maybe. So I was able to like download that on my computer and then just like upload it to a server. But I think we could also pull them directly from the cluster if we wanted.
For me, my data is kind of small. I only have 600 murals. And actually to simulate like you can do it yourself, I just took screenshots by hand for the ones I wanted, just to make it like really anyone can do this. I am going to look into making this a more automated process for bigger projects, but really you could literally do it that way. And that's what I was doing. And therefore I was able to run it on my very bad laptop.
Yeah, I also have my own computer server. And there are some cloud computing resources, such as Google Cloud, which are freely to use.
All right. The question for Riley from the same person, Yunus, looks like they know you. I noticed you used ResNet, but as far as I know, clip models or clip architecture have also proven highly effective on this kind of approach. Did you have a chance to try out these models?
Hi, it's good to see you digitally here. No, so I'm actually not familiar with clip models. So I'll have to like do some research. Maybe you can send me an email. But in general, like the results from our models were so good that I haven't really thought much about like other methods for it. I mean, certainly, we like played around a lot with like hyperparameters and kind of different ways of specifying the ResNet model, but like I know like computer scientists are always trying to squeeze the extra like 1 or 2% in accuracy out, but like for me, when I was like, wow, we're doing enclosure with like 89% accuracy essentially, I was like, okay, maybe it's not worth my time like building up a new computer vision model, and I should just like you know do the criminology research from this point forward. But definitely, I mean, there's always new models coming out all the time. So like, I was trying to develop my own segmentation model, and like, I was starting to do it with YOLO version 8. I had like real life stuff happen. By the time I came back to it, it was like YOLO 11 was out. You know what I mean? So like, things move really fast. It's kind of hard to say on top of it. But yeah, I'm always like on the hunt for the best tool. So send me an email.
And the last question, for Dr. Kang. Thank you. If you were to apply this methodology in other cities, would there be a way to access the code or data related to your method?
Yeah, so unfortunately, the data cannot be accessed because it is a private data. But there are some openly available data sets such as place pulse. And for the model, there are also some available like open source data models. Actually all of those methods we mentioned today, I think except the ChatGPT 4, all of those are open source, so you can access it as long as you have the expertise. But if you do not have some background in computer science, my suggestion is, for example, you could collaborate with some others. For example, feel free to reach out to me or other panels today, because they may have such kind of technical background to help you set up that model. And also, I feel like, yeah, there is a global data set called Place Pulse, and there are some other image-based data sets, like all openly available. They have been widely used.
We are going to thank you, Yuhao. We are going to transfer these questions to a document, and we would be making these answers available. So I guess these names of softwares and platforms will be written, so you might have a look on the website later on, just to get this information. We are going also to share this by email. Joanna's also comment on that UCLA, Department of Security and Crime Science, provides or have a lot of courses for programming quantitative data. So it seems that there are other universities that have a possibility of offering these kinds of courses for people that are starting working on these areas, right? And there is another comment from Camille Gomid, very interesting. She says, I work in a nonprofit that geomaps incident of sexual violence. And in fact, over 8% of our reports are from during the day. So the question is to what extent we would be able, for instance, perhaps to use Google Street View to map places where people were sexually harassed. So the web page of their nonprofit is Safety City in India.
I think it would be cool to open up the floor if panelists have questions, if you have questions for each other. I know since your head has been in this really rapidly developing area, as you've mentioned, I'm sure you're running into obstacles, opportunities. Do you have lessons that you've learned from your work, ways that you would suggest to others to go about in order to make their life easier as they're trying to import all these new tools into criminology, or or from criminology away, to urban planning, for example?
I guess I would say there's a lot of options out there for tools, and you should think really holistically about what works well for you. So for example, for my project, it was really important that our training data set was geographically representative of Chicago. You know, like I wanted Chicago. I didn't care if like LA or New York or like, London was in there, but like for some kinds of projects, you would really want that. And so, for me to get like a data set that actually worked for my project, I had to collect my own. But certainly for like other kinds, what you need already exists. You know what I mean? So I just think really holistically about like, is the tool that's online and easy for you to use, does it give you kind of like the metrics that you need, or is it like processing the information that helps answer your research question? I'd say always like keep the theory and the research question at the forefront, and then use the methodology to support that.
Yeah, I would also say that it kind of gets interesting with the limitations of your project. So for me, because I was using murals, I thought like, okay, I could just kind of scrape it, like take it off the internet to use it. But when I went and did it myself, I realized that the addresses that I got very, very graciously from a nonprofit organization were not always correct. So sometimes I would have downloaded like random streets, essentially. So there is such an important aspect of like digging your hands in, getting dirty, doing it yourself to figure out what's gonna go wrong when you farm this out to AI. It's the kind of thing where when I had my research assistant, I put together a code book. I thought everything was super clear. His questions showed me how unclear things were. And that's not the kind of feedback that ChatGPT will give you or that any model will give you. That's the kind of thing you find out. And that's similar, like, I was told, like, as a criminologist, you take a ride with a police officer, you visit a prison. This is the kind of thing that doesn't come up unless you get in the weeds. So it's just one more thing to flag when you're thinking about using this for your data. You will lose some of that personal experience that will allow you to be the expert.
Such a great point in terms of data quality and the process quality, I would say. It's really important along the process, right? Very good point.
I also like Cheyenne's approach to being very careful about how much missing data across space and across time. That is such an important issue when it comes to big data in general, because missing data is not always appropriately addressed. Sometimes it's treated as zeros. So digging in really closely, at the very least, to understand if the missing data is properly coded is really essential, especially when you're dealing with giant data sets. This is an important one. How do you have any insights as to lessons you've learned on in your trajectory to where you are so far?
Yeah, thanks for the question. I feel like for me, it's always crucial to have interdisciplinary collaboration. For instance, I had background in computer science, more technical perspective, but there has been a huge gap between the technology and the real world applications. So it is necessary to talk with different people to broaden like your insights, to broaden the perspectives. I really learn a lot from my collaborators because they have very strong theoretical foundations and they can point out the specific questions. So for me, I think it is important to talk with people from different domains because for each time, if you talk with some people with different background, you can always learn something new and something fun. Yeah.
Cheyenne, for you?
Yeah, I think I would sort of echo what Maya already said. Doing this project, we're specifically focusing on limitations and problems, which can be a lot. And something I did right in the beginning while, our model was running was manually inspect the images and make these notes. And I had an undergrad help me with this too. And we were making notes like what is looking weird, like are we seeing changes? And so before we even had the results and could look at this variation that the model was outputting, we already had a really good sense of what problems were going to come up based on what we knew the model to do and based on what we were seeing in the images. So the things like when we're seeing trees covering stuff up or the angle changing of the photo. So yeah, I would just say what Maya said, like being really in the weeds with the method and knowing exactly like everything that could go wrong, and seeing how you can account for that.
Mhm. Okay, I think we are about, I think we should wrap up, right, Karina?
Yep, I was only gonna say a giant big thank you so much to everyone who participated, sharing from your insights, your efforts, and all the cool projects. Thank you to the attendees and all the thoughtful questions. I'll let you, Vanya, sort of give more details about where people can follow up and find the recording of this presentation. But before that, I want to remind everyone before you leave, please join us for the division reception on Thursday, November 14th, 6 to 8 at the Fang Restaurant, or the awards ceremony at ASC in San Francisco on Friday at 9:30 at the Golden Gate C3 B2 level. So with that, I want to say thank you so much to Vanya and also your team for getting everything moving so smoothly.
Thank you, Corina, and for the collaboration. I think it has been for interesting webinars, and thank you for the support. I'm looking forward to meet you all next week in San Francisco, and for our team here in Stockholm, we will make sure that we get the recordings available to you, and we will share with all that have registered for the webinar. Thank you so much, the KGA, the Safe Places, Gabriel, Ioannis, Jonathan. Thank you, and see you soon.